Good evening, everyone. On behalf of the Incose Chesapeake chapter, I'd like to welcome you to our dinner and now our lecture portion of the evening. And it is my definite pleasure tonight to introduce our speaker, Dr. Herb Frey, who is now retired from NASA. He was the chief of, and I have to read this because I can never remember it, the Planetary Geology, Geophysics and Geochemistry Lab at NASA's Goddard facility, Space Flight Center. And he grew up as a child, always young boy, always interested in astronomy. And I have to say, I really envy him because at age 10 or 11, he knew what he wanted to do for the rest of his life, and he did it. He got into a 38-year career in space exploration, astronomy, and thoroughly loved what he did. And I don't want to take away from the talk, so without further ado, we'll get him up on the stage. But please give a warm welcome to Dr. Frey. Oh, one other thing that I did want to say was this is so apropos to engineering because as you listen tonight, and I think you'll be thoroughly entertained, that the thought may not escape you that this could be one of the greatest engineering projects ever attempted by humankind.
Thanks, Mark. Can everybody hear me okay with the lavalier? Okay. Very much appreciate being invited here to share some of these thoughts with you. In the interest of full transparency and disclaimer, yes, I worked at NASA for a very, very long time. I was actually working at Goddard, one capacity or another, for 42 years, and a civil servant for over 37. But I want to make it clear that the things you're hearing tonight are my ideas and may not reflect the actual viewpoint of the agency. And in fact, I'm sure a couple of things I'm going to say would probably not be that much appreciated by the agency. So just keep that in mind as we go through this. I have a lot of material I'd like to cover today, so I'm going to ask you, if you would, to hold your questions to the very end, okay? And we'll just get started and go through this. Okay, this presentation will have several parts. We'll talk about some of the very early observations of Mars. We'll look at spacecraft observations of Mars and what they've told us about the environment, and then we'll look and see how the environment of Mars has actually changed over time. We'll get into the question of whether humans can actually even go to Mars and then live there, and that's what this is basically all about. Can we live on Mars? And should we actually try to do that? So, why are we so interested in exploring Mars? Okay, we've been exploring Mars with spacecraft for more than 50 years, and for a century before that with telescopes. It's because Mars is the most Earth-like body in the solar system and the one that might support some kind of life. And what I'd like to do first here is to actually summarize 50 years of Mars exploration by NASA with basically this little 4-minute video. Just give us a minute while this actually links. Here we go. There we go. Okay. It stopped on me here. Hold on. Here we go.
Hey, there we go. There she goes. Yeah, that's data.
There is some sort of a pattern to the data, and we have now full confidence that this does indeed correspond to a photograph of Mars.
Based on your preliminary analysis of this data, can you describe what you see on Mars?
Yes, it's there.
Coming back with touchdown.
Led by the extraordinary men and women of NASA and our Jet Propulsion Laboratory. Right now, the wheels of Curiosity have begun to blaze the trail for human footprints on Mars.
Well, today on Mars, history was made on Earth. The successful landing of Curiosity will stand as an American point of pride far into the future.
I just wanted to call and say congratulations to the entire Mars Science Laboratory team and really all of JPL. You guys should be remarkably proud.
Actually, despite the amazing engineering and technical accomplishments that that movie reveals, the thing that means most to me is the reaction of the people involved. This is all about the people who made it happen. So the question is or was there life on Mars? And the answer is, of course there is. Just Google it. There's the Mars alligator, hermit crab, maybe a horseshoe crab down here, a couple of rodents, a Mars lizard in the daytime, and the one at night when it gets 170 degrees colder. Puxatawny Phil has a cousin on Mars who says it's going to be a very long and cold, dry spell on Mars. There's even published work. You may know that never peer-reviewed scientific journal called the World Weekly News that used to appear on the supermarket checkouts. Okay, this is actually a picture from a strange breed of cats found on Mars shortly after the Spirit rover actually landed. This is the Discovery photo. And of course, the question is, what do they actually eat? It's those rodents that we saw a moment ago. You've seen the face on Mars. You may not have seen the face and body on Mars, okay? And you probably never saw the aliens that are actually guarding this, okay? This probably will not pass peer review. But there's also evidence from artifacts that maybe there's advanced life forms, like little tiny pyramids, a lost sneaker down here. Apparently there is coffee there. Starbucks is already there. And spoons to stir it with, a Walmart, and a McDonald's, home of the McMarsburger. Are those signs of intelligent life? I'm not sure. Okay. Then there's the fossil monuments and other things, little Yetis. These are about 4 inches high, so they're not terribly threatening. Another one here, probably on his way to that pyramid, and a skeleton of one, and so on. Okay, Photoshop and photo misinterpretations aside, is there any observations that does suggest that Mars might have some life? The earliest observations of Mars were done by Galileo, who invented the telescope in 1610. And very soon, better telescopes were being invented, and it wasn't that much longer, within a century or two, that we started making maps of Mars as it appeared through the telescopes. But the real fun started with what I like to call the Canali controversy, okay? Giovanni Schiaparelli, an Italian astronomer, made lots of observations of Mars in the late 1800s, and he drew many, many maps, and he found evidence, saw recorded numerous linear features, which he called canali, Italian for channel-like. These are two of his maps right there, okay? Camille Flammarion, who's a French astronomer, well-known at the time, in 1982 wrote a book called The Planet Mars, and in that book he said, to him, the canali resembled man-made canals, which an intelligent race could use to distribute water across a dying world. Flammarion was also quite an observer of Mars. He analyzed over 2,600 drawings. This is one of his maps showing something like 2 large oceans, 22 lakes, 4 sea channels, and 5 continents. This is from one of his books, a rendition of the so-called canali that suggested that they were artificial. In his book in 1982, he said it would be wrong to deny that Mars could be inhabited by human species whose intelligence and methods of action could be far superior to our own. Flammarion was very enthusiastic about canals, but his enthusiasm was nothing compared to that of Percival Lowell. Percival Lowell was a rich a Bostonian who actually went to Flagstaff, Arizona, and built an observatory for the express purpose of studying Mars, because he believed that what Schiaparelli had actually seen were, in fact, artificial canals built by a heroic race of intelligent creatures, as he called it. This is actually Lowell at his observatory in Flagstaff. This is a painting of Lowell's idea about these canals by Chesley Bonestell. He actually thought they were waterways that were carrying water from the melting polar caps down to the dark areas that were vegetation, and they were irrigating the vegetation. His critics said, hey, there's no way with our telescopes you could actually see the canal. He said, we don't see the canal. We see the irrigated strip of land on either side where the vegetation is growing, which is much wider. He wrote several popular books, which make excellent reading. And in one of those, he said that Mars is inhabited by beings of some sort or other we may consider as certain as it is uncertain what these beings may be. He had help. At about the same time Lowell was observing, H.G. Wells wrote War of the Worlds, which has since been turned into at least 2 movies, the most recent by Steven Spielberg. The New York Times, that fake news organization, was very enamored of the canals of Mars. And here are some of the postings talking about Lowell's ideas about the canals on Mars. There were others who did not see canals on Mars. Eugene Antoniani, invited to France by Flammarion, actually, used the 83 centimeter telescope at the Meudon Observatory, which is brand new, which is the best telescope at its time, to observe Mars. And he came to the conclusion these were optical illusions. He actually published a comparison of Schiaparelli's observations of the Elysium region of Mars with his own observations here, and concluded that what people were thinking were straight lines were actually disconnected features that the eye was actually connecting for them. But Lowell was unmoved by data, okay? Shortly before his death, he summarized his views here. Since the theory of intelligent life on the planet was first enunciated 21 years ago, every new fact discovered has been found to be in accord with it, okay? Not a single thing has been detected which it does not explain. This is really remarkable. It has, of course, met the fate of any new idea. That is to say, some people choose not to believe it. But he was very persuasive, and his ideas went on decades after his death. Helped in part by popular writings about it based on his ideas. Edgar Rice Burroughs, who is famous for writing the Tarzan series, also wrote a series of books about John Carter on Mars, and they are actually listed here. The first one is called A Princess of Mars. These were published, and they make excellent reading as well. And so the idea was that the Lowell idea of canals went on and on. And in fact, Burroughs actually inspired a number of very famous science fiction writers, Ray Bradbury, who wrote the Martian Chronicles, Robert Heinlein, Arthur Clarke, and the like, to do their writings about Mars as well. If you look at Wikipedia, it lists 72 works of fiction about Mars before 1965, okay, and only 61 after that. And you can see how the number drops off radically right here about 1965. Why? Because in 1965, we actually got our first real close look at Mars. But up until then, the idea had become pretty much established in many people's minds that Mars supported some kind of life. Maybe actually not canals and canal builders, maybe just simple vegetation, but some form of life existed on Mars. Maybe there were giant engineering projects, or maybe there were at least the relics of those from a bygone era. This was an idea that was very common with people of the time. And we probably shouldn't blame the early observers too much, because observing Mars from the Earth is tough. It's really tough. This is an image from the Hubble Space Telescope, which is the best telescope off the ground, not having to deal with our own atmospheric distortion of what we're trying to look at. And this is about the best image you get of Mars, and it doesn't have very much detail. And there are times when Mars is covered by dust storms, and that makes it even worse. If you want to really look and see what Mars is about, you actually have to go there. And we did that for the first time in 1965. Mars is not an easy place to go to. The success rate overall is not that great. This lists a number of missions by NASA, Russia, and the former Soviet Union, and other nations, and all about 55 missions have been sent to Mars. The overall success rate is about 25%. NASA's success rate is much higher, okay? But in general, Mars has not been kind to the spacecraft that have been sent there to actually explore it. This is the rack-up for NASA. It shows how things have changed over the decades. These are organized by decades. Early flybys followed by early orbiters and landers, a gap for actually almost 20 years between the Viking spacecraft and the Mars Global Surveyor. Landers and now rovers, and with the Mars 2020 coming up next year. This is just a gallery of these things. The early flyby, Mariner 4 in 1965, which gave us our first look at Mars, followed by two similar sort of spacecraft in 1969, early orbiters from Mariner 9 and the Viking orbiter, which is actually a orbiter-lander combination. The Mars Global Surveyor in 1997, that's a mission that I was fortunate to be part of. And there are still working at Mars today 6 orbiters, okay? 3 of which are NASA's that are shown here, and 2 from ESA, and 1 from the Indian Space Agency as well. That's the rack-up of objects that have been successful at Mars in terms of orbiters, flybys, and the like. The early flyby mission by Mariner 4 actually gave us our first look at the planet. It gave us 22 pictures that looked something like this, okay? It showed that a very cratered moon-like surface, a very low atmospheric pressure, a daytime temperature which was very cold, and no evidence for a magnetic field. It was followed by the tandem flyby of Mariner 6 and 7 here, with more images that again showed a very moon-like surface. So even these early flybys, with their very brief encounters with the planet, settled some basic scientific issues. Mars seemed, based on this, more like the moon than the Earth, so it was probably not a good place to expect canals or canal builders. The orbiters changed the picture. Orbiters have the advantage of getting repeat observations, especially if you put them into a polar orbit. And so you can see the whole planet with enough time. And that started first with Mariner 9, and then with the Viking orbiters. And we found that there were areas of Mars that were much more Earth-like, in the sense that they showed evidence for volcanic, tectonic, and fluvial processes going on the surface that the earlier flybys had not. So you see these dried up river valleys and like this, and you see this giant volcano, which is the biggest one in the solar system, and these huge rift canyons, okay? So the orbiters changed the picture, okay? What have they actually told us, the flybys and orbiters? They've told us that geologically Mars is kind of like a combination of the moon and the Earth. It's kind of like a moon trying to become an Earth. It's got a lot of moon-like features, but it's also got some Earth-like features, okay? They told us that there are seasonal changes that occur. We can watch the polar caps grow in the wintertime and melt in the summertime, as shown over here. We also see evidence for episodic changes, like impact craters that weren't there a few years ago and now have suddenly occurred. We know the surface has been modified by wind and by water. There are dunes on Mars, much like those we see on the Earth, and they migrate over time. Even though there's a very thin atmosphere, it can produce these kinds of dune-like features. We see evidence for water erosion on the surface, which is pretty clear. liquid water did exist on the surface of Mars at one time. And something that's going to turn out to be very important to what we're going to say a little bit later, Mars no longer has a global magnetic field. The evidence is that it used to. We see features on the surface, what are called magnetic anomalies, which are magnetized parts of the crust. So Mars at one time had a global magnetic field, but today does not have an active dynamo like the Earth does. And that will turn out to be very, very important. This actually has a significant impact on how Mars changed over time. So this is a view of Mars, which is based on topography. This comes from the MOLA instrument on the Mars Global Surveyor, the mission that I was fortunate to be part of. And what you're basically looking here is topography. The blues are low areas, the reds and the whites are the high areas. And what you see right here is a very heavily cratered surface called the Southern Highlands, and a more sparsely cratered surface called the Northern Lowlands. And in this respect, Mars looks a lot like the Moon. But we also have things that are a little bit different. Giant impact basins like we see on the Moon, but also giant shield volcanoes like the Hawaiian Islands, for example, or the Galapagos Islands, okay? And there are even smaller shield volcanoes over here in what's called the Elysium region. Equally more Earth-like are these giant rift canyons, which are somewhat like the East African Rift, places where on the Earth plates are beginning to break apart. And, whoops, apologies. And the other thing I wanted to show you was these outflow channels where it's pretty clear that water has actually eroded the surface and carried material down into the northern lowlands. There's lots of evidence that water was active on the surface of Mars in the past. There are old dried up river channels with meanders. There are these outflow channels with teardrop-shaped islands that have been eroded into the surface. There's even systems of tributaries that are shown in some parts of Mars, like what we see here. There's evidence that the northern lowlands are bordered by features that look like shorelines. We also have chemical evidence for water acting on the surface of Mars. What's shown here in false color in green are actually clays. Clays are materials that are formed in the presence of water, modified in the presence of water. The interesting thing is that when you look at where those modified areas are, the clay units, they are in the lower part of what's called the stratigraphic column. Stratigraphic column is basically a record of time. The old things are at the bottom, the young things are at the top. And the parts of Mars that were modified are all the old ones. There was a time when Mars was wet, and a time after which Mars has been basically continuously dry. We do know that there's ice at or near the surface on Mars. We see it in the polar regions when the seasonal ice cap goes away. Seasonal ice cap is carbon dioxide. We see exposed a water ice polar cap. We see features that look very glacial-like, okay, which probably suggests ice under a covering of dust and rock, some of which is quite large. This particular one is as large as the Lake Superior. And we do know that there is hydrogen coming off the upper parts of the surface from the neutron experiment on Mars Odyssey, and this is thought to be derived from water at the near surface. Okay, most interesting is a result that came out just a couple of years ago from ESA, from the Mars Express mission that's been there for quite a long time now. The radar on that actually produced an image. It's a ground-penetrating radar. Produced an image like this, which showed a highly reflective layer down here, the interpretation of which is that this is actually probably water, liquid water, very salty liquid water. And the analogy that is often used is Lake Vostok in Antarctica. If this is true, there may be places where water not is just ice near the surface, but at some depth below the surface, there may be places where it's still retained in a liquid form. We've also been to the surface with landers and rovers, many of which have not been successful. The upside-down triangles here show ones that didn't work. NASA's record here, again, is somewhat better. InSight over here is the most recent of those that have been put on the surface by NASA. just last year. That's a lander that was designed to actually look for evidence of Mars quakes on Mars. So this is a rack-up of what they look like. The first lander on Mars was the Viking landers 1 and 2, okay? Followed more than 20 years later by the Pathfinder lander, which was actually the carrier for the Mars Pathfinder Sojourner rover. The Mars Scout Phoenix landed in the Arctic and found clear evidence for water ice just below the surface. And the InSight lander that landed last year is actually looking for Mars quakes right now. These are the rovers that have been very successful on Mars. The Pathfinder Sojourner rover is about the size of a desktop copier. The Mars exploration rovers, 2 of them, Spirit and Opportunity, are about the size of a small golf cart, and Curiosity is likened to a small SUV. These 2 were landed using airbag technology, as you saw in the video. This one is too big to do that and was actually landed using what's called a sky crane type of technology. I have to give a shout out to the Mars exploration rovers. These 2 guys, which landed in 2004, okay, were designed to rove about 600 meters across the surface and to last for about 90 sols or 90 Mars days, okay? Spirit lasted until 2010, went over 7 kilometers, okay? It was supposed to go this far, about the distance from where it landed to Bonneville Crater. After successfully going to Bonneville Crater, it did this traverse out here to the Columbia Hills for many years after that. Opportunity did even more. It landed here in the Eagle Crater. It was designed to go about this distance, which would have put it here near Endurance Crater, which it went to and visited. And then after that, to Victoria Crater, and finally to this very much larger Endeavour Crater before the dust storm of last year actually finally killed it off. It rove over 45 kilometers, broke the record for any rover off of the Earth, and lasted over 5,000 sols. An incredible accomplishment. What have we learned about water on Mars from the landers and rovers? There's lots of evidence, chemical evidence, for example, for altered materials that were altered in the presence of water. We see structural indications of layering and sedimentary deposits that were probably laid down in water-rich terrains. This is supposed to be an old dried-up stream bed. Curiosity landed in what's called Gale Crater, which people think was a crater lake at one time filled with water, and there's pretty clear evidence that conditions across that varied and may have been able to support microbial life. Mars had in the past the ingredients and watery environment conditions that could have supported life. Let's compare the Earth today with Mars today. Okay, the environment that we see there. The Earth has a very thick atmosphere, 1,000 millibars, nitrogen and oxygen atmosphere. It has a greenhouse warming effect of about 34 degrees. Its average surface temperature is about 15 degrees C. It has ozone to protect us from the sun's ultraviolet light. And this is the average surface material on the Earth, liquid water. Mars has a thin, ultra-thin atmosphere, only 7 millibars on average in thickness. It's carbon dioxide. The greenhouse effect of this is very minor, only about 5 degrees centigrade. Its average surface temperature is minus 50 degrees centigrade, no ozone in the atmosphere, and this is the average surface material that we see on Mars. These 2 objects are very, very, very different. And frankly, conditions on Mars today are not very supportive of life there. But things were very different in the past. Things were different before Mars experienced what I call a catastrophic climate change. What happened is Mars lost its magnetic field very early in its history. The magnetic field, our magnetic field, for example, protects the atmosphere from erosion by the solar wind, by particles from the solar wind. And so when Mars lost that, the atmosphere was exposed to solar wind erosion, which gradually stripped away the greenhouse gases that were keeping it warm and allowing water to exist on the surface. And over time, turning it into the dry, cold planet that we see today, which cannot support liquid water at its surface. MAVEN and Curiosity, MAVEN the orbiter and Curiosity the rover have shown that the atmosphere was much thicker in the past. There's much evidence for that now. And over time was lost after the magnetic field went away. And the thicker CO2 atmosphere would mean warmer surface temperatures, which would allow liquid water to actually survive on the surface. Mars used to be a warmer, wetter place than it is today. The evidence is very strong that there was past liquid water on the surface, and today there's at least ice in some places on Mars. It had the right environment to support life. And because life is very adaptive, you have to ask the question, if life ever did start on Mars, could it have survived somehow this catastrophic climate change, which we'll come back and talk about a little bit later. So searching for life was and remains a worthwhile thing to do, I believe. The first serious attempt to do this was in 1976 with the Viking landers, okay? Both Viking landers contained biology experiments which were designed to look for life there, okay? They did it in different ways. Oops, apologies. They did it in different ways. The one I want to talk about most is what's called the labeled release experiment, one of the three experiments that are actually shown here. The labeled release experiment, okay, was designed to look for products of metabolism. And both landers produced a positive result for that test. Now, before it was launched, okay, before the launch occurred, the labeled release experiment was tested on terrestrial soils, Death Valley, Antarctica, and things like that. It always showed positive for life because life exists almost everywhere on the Earth. As a control, samples were heated to 160 degrees to kill off life, and every one of those tests was now negative. In other words, the control actually worked. They actually used sterile soils to test the experiment, like from the moon, and those produced negative results. So this experiment worked in terms of being able to tell whether something on Earth or on the moon actually had any life in it. Here's how it worked. When the lander scooped up some material, it deposited it in here, and then a nutrient solution containing radioactive carbon, carbon-14, was put onto that soil. Then the atmosphere over that was monitored over time to see if anything came back out that carried that carbon-14 tracer. This is the result. When they injected the material in the soil, boom, they saw this response, which on Earth would have clearly indicated life. They did a control test after heating it, and that was negative, as expected based on what had been done on the Earth. So did the label release actually detect metabolizing life on Mars? The problem was there were other experiments on Mars which failed to find evidence for organic material on Mars, okay? And they thought this was due to highly reactive soil chemistries, okay? And in particular, since there was no trace of organic material, many people thought that this experiment somehow had been fooled or failed, okay? The Phoenix lander in 2009 found a chemical called perchlorate on Mars. Perchlorate, when you, in the presence of organic material, when you heat that to 160 degrees C, it was done in Viking, okay? It has the ability to actually destroy the organic material. Now, so it is possible that the perchlorates on Mars actually fooled the Viking, not the label release experiment, but the other two. They may have actually destroyed the organic material that those experiments failed to find. And so it is possible that the labeled release might actually have detected life. But the results are at best ambiguous. And quoting from Carl Sagan, extraordinary claims require extraordinary evidence, but absence of evidence is not evidence of absence. What this did do is change the strategy for how we go about looking for life on Mars. Viking tried to test for existing life on Mars by looking for a life process, metabolism, okay? And since the results were ambiguous, maybe there's not existing life on Mars, and so the strategy changed to were there ever environments on Mars that could have supported life? And that's where Spirit and Rover and Phoenix come in, and the so-called, and the famous phrase, follow the water, okay, actually guided these missions. They went looking to see if there was evidence for water in the past on Mars, and they found, yes, that was indeed the case. Water did exist in the past on Mars, and Mars previously had what might be considered habitable environments. Having done that, the theme for the Curiosity rover is now follow the carbon. Is there any evidence for organic materials, which we've now found, and possible biosignatures? Here are two results that are particularly intriguing. Curiosity found some organic molecules, sulfur-based organic molecules, the examples of which are shown down here, in the top 5 centimeters of the soil in Gale Crater. These are thought to have survived for several billion years based on age determinations of the material in Gale Crater, of actually Gale Crater itself. So that's interesting. There is organic material on Mars, which again implicates the perchlorate in having destroyed it for the Viking experiments. The other thing that's really intriguing, although not in any way definitive, is that there's methane emission that is occurring on Mars, okay? This actually shows 3 years of observations. And methane, the amounts are very, very small, but methane actually peaks in the warm months and then declines in the winter months over 3 Martian years. Methane can be produced by geological processes, but it can also be produced by biology. Cows are the typical example that everybody talks about as producing methane. So, what do we know about the possibility of life and living on Mars after 54 years of exploration? We don't have a definite answer to the question of whether or not there was life on Mars. The Mars environment has changed greatly over its history, going from wet and warm to very cold and very, very dry. And the current Mars environment is not very supportive of life, either for indigenous life or for us if we wanted to go there. Can we live there? Can we even go there? Is the real goal human exploration of Mars and eventually a permanent human presence? My original hope was that I could be part of that. My later hope was I live long enough to actually see it happen. And my current hope is that when we do it, we actually do it right. I'm going to share a little personal story here with you, okay? I grew up wanting to be the first guy to walk on Mars, the first guy out of the first manned mission to Mars right here. Then I came to realize that in order to be the first guy out, you had to look like George Clooney or Arnold Schwarzenegger or some Hollywood movie star, and I surely did not qualify for that, okay? So, but I thought they might send a scientist for the second one, so so like others reaching for the stars, my boyhood dream to walk on Mars, to hold a rock from that far place, across the red-hued dunes to race, to walk down ancient waterways and dream of bygone warmer days. Okay, so when can I go, okay? 1969, summer of 1969, I'm in my first year of graduate school at the University of Maryland here. We watched Neil Armstrong step out on the moon, and we know the manned space program is on schedule to get us to Mars in 15 or 20 years, and I'm exactly the right age. I'll be 37, a perfect age for an astronaut, right? I could be the first guy to actually set foot on Mars. What happened? President killed the Apollo program, eliminating the last 3 missions and pushing out indefinitely any possibility of a manned mission to Mars. And in the 3 decades since that happened, we've come to learn a lot more about Mars, and it's not an easy place to get to or work on. In fact, it's downright dangerous to try. 50 years later, we're still no closer to getting there than we were in 1969, in my view. I'll explain. Here are 7, this is kind of a cartoon, 7 ways in which you could be killed trying to get to Mars. Your spacecraft could blow up in the launch pad. You could get cancer from radiation on the journey out. You could crash on Mars trying to land. The low gravity ruins your bones and muscles. You develop a leak in your spacesuit or habitat. The Mars soil is toxic and kills you. Or you just go crazy because you can't stand those people that you're with anymore. Okay? Let's talk about a couple of the real serious issues, okay? The first problem is that it's a long, long mission, 2 to 3 years at most, and that has to do with the different orbital periods of the two planets, okay? You can really only launch to Mars every 26 months if you're going to do it on a minimum energy trajectory, okay? So in the lowest energy case, it takes 9 months to get there and back. That's 540 days, plus about 500 days on Mars waiting for the configuration of the planets to be about right. Second problem is that there are some very serious medical issues. Radiation is a real problem. Okay, what's shown here in green, notice this is a logarithmic scale here. This is a dose equivalent measurement here. What's shown here in green is the lifetime limit for radiation exposure for a DOE worker. What's shown here are 6 months on the ISS, the International Space Station. This is the 180-day trip to Mars, and of course you have to come back, so you double that, okay? And this is 500 days on Mars, the radiation exposure that you would have. Radiation is a very serious problem, and we don't have an answer to it yet. Another serious medical issue is months of weightlessness and isolation. We know that there are debilitating physical things that occur in weightlessness over long periods of time. The work that Scott Kelly has done in comparison with his Earthbound twin on the space station, he spent a year there, has shown that there are severe problems that occur as a result of prolonged weightlessness. There's also a lot of possible psychological problems and other things that are associated with isolation and being separated from Earth and from the people for long periods of time. Whoops, sorry about that. So, when could we actually expect to put humans on Mars, given some of these problems? This is from the Smithsonian Air and Space Ask an Astronaut from their magazine there from actually April of 2016. The question that was asked is, do we have the knowledge to send humans to Mars and bring them safely back? The basic answer is no. We don't yet have all the technologies we need to get to Mars and come back safely. And he pointed out 3 things. We don't have reliable life support that can keep a crew alive that long. It's kind of like putting a crew in a submarine, submerging for 3 years and never coming to the surface for 3 years, and we can't do that here on Earth. And so we're not able to do something like that from Mars. Secondly, we don't know how to land a heavy spacecraft on Mars. The biggest thing we've landed there is Curiosity. It's 1 ton. Manned landings will require 10, 20, or maybe 50 tons, and we don't know how to do that in the very thin atmosphere of Mars where parachutes can't do it, okay? Or where you're going to carry huge amounts of fuel to actually break it. We don't have this technology yet. Lastly, there's an unsolved problem of radiation exposure, which I mentioned before. He's suggesting NASA has about 20 years ahead of it to solve this problem. He says, yeah, I'm optimistic we'll conquer these challenges, but it may be 2040 before we can actually put somebody on the surface of Mars. But Elon Musk says we can do it by the 2020s, right? Here's his grand plan to actually build a colony on Mars. In 2022, he's going to launch 2 cargo vehicles to Mars, confirm that there's water there, identify hazards, put in place power, mining, and life support infrastructure. 2 years later, he's going to send 4 spacecraft to Mars, 2 cargo, 2 crewed, put the first people there. They'll build propellant tank production facilities and the like, and so on. Later, 100 passenger starships will launch from Earth to orbit, refuel, and go to Mars, and this is his grand plan. He's even recently told us where he's going to land, okay? The landing site for what he calls Mars Base Alpha is going to be on the border between Arcadia and Amazonas Peninsula, 2 smooth volcanic plain areas on Mars, just west of the big volcano on Mars, okay? This volcanic area is thought to contain numerous lava tubes, which could be a good place to put a habitat. SpaceX is doing, I think, a very important job of thinking outside the box and thinking about one aspect of this problem. They are talking about the Mars transportation infrastructure that would be needed to get people to Mars, to actually facilitate colonization. This is their emphasis, and they have made some significant progress on this. But if you listen to his presentations and everything that's coming out of there, missing on all of that are the details of the colony infrastructure that would be needed to keep people alive. The habitat, power, air, water extraction, food production, and so on. That is not what's being talked about. And colonizing Mars is a lot more than just getting there. We are, in my view, a very, very long way from being able to plunk down a colony on Mars and have it survive, let alone it thrive. No way in the 2020s, in my view. So when will this actually happen? Recent proclamations by the current administration, 25 years. Last year they said it would take 25 years if we can find some way to protect people from radiation, and if we can develop the landing and takeoff technology that we don't yet have. The chief scientist, Jim Green, recently said by 2040, maybe. Okay, the previous administration said we were going to do it by the 2030s, so we seem to be losing ground. But let's assume we're actually going to be able to visit Mars in the 2040s, or maybe 2050s. Should this lead to a permanent presence there? Well, sure, right? We go, we stay. Except this is going to be orders of magnitude harder than establishing permanent bases in Antarctica, which is often used as a comparison. This is McMurdo Station in Antarctica. It was established in 1956. It is a modern-day science station with with harbor and airfields and over 100 buildings and the like. And most of the personnel there, which number 1258 in summer and 250 in the winter, are there to support scientific endeavors. This station does have some common characteristics with the Mars base. They both will have periods of almost total darkness. Sun doesn't rise in the winter in Antarctica. Mars has global dust storms that cover the planet for months, okay? Both will have large power requirements. In McMurdo, they're now using mostly diesel generators. They did use nuclear power for a short period of time, for about a year or two, and maybe as much as 10 years, and they no longer do. Mars, solar power can work, but you're probably going to need nuclear because of the dust storm problem. They both have to be resupplied. Neither of them are self-sufficient, okay? McMurdo's resupplied every summer, and if there's an emergency, they can get there in the winter. On Mars, it doesn't happen. Every 26 months is the schedule that you have to keep for resupplying it. The major differences are the real problem. The travel distance of McMurdo is less than 6,000 miles. Mars, at its closest approach to the Earth, is 36 million miles away, and the actual travel distance is much greater because of the arc that you have to take because of the orbital configurations. The travel time to Mars, one way, 6 to 9 months, compared with hours or days to McMurdo. Communication, again, very much longer for Mars than for McMurdo, but this is the real problem. Whoops, sorry about that. In McMurdo, you have breathable air. You have readily available water. It's ice, but you can turn it into liquid. And the temperatures really only require that you have warm clothing. On Mars, none of this is true. On Mars, you have to isolate yourself from the environment. And there's various comparisons and there's some details here that shows how Mars is very different from the Earth. And by the way, I'm going to make this thing available as a PDF file for all of you folks, so you can read these if you want in the future. But it's not going to be easy on Mars. A staged approach to exploration of Mars is probably the right way to do. First, we go to a few places of scientific interest, stay for a few days, come back. Stay for a short time and then come back. Next, build a reusable but permanent station which can be periodically reoccupied. And then over time, maybe that grows into something for continual occupation. Problem is, we can't even do the first step right now. We don't know how to do this. My own belief is that what's described in tonight's drawing prize, The Martian, is probably a good example of how we will actually do it. Early human exploration will involve a series of missions to scientifically interesting places where we will send the necessary equipment in advance, okay, of the astronauts actually getting there. This includes an ascent vehicle to get off the surface, It includes a fuel manufacturing station to provide the propellant for that ascent vehicle, a habitat, pressurized rovers, and like. You also will need some kind of a reusable orbit-to-orbit transfer spacecraft to get us from Earth to Mars orbit and back again. Other than solar panels on robotic landers, none of these things have been built, okay? None of these things have been used on another planet. The things that are in red here are basic concept stage only. The ones in orange are prototypes have been tried here on the Earth, like, for example, pressurized rovers and things like that. Long-term occupancy has a whole bunch of additional problems. You need habitat and shelter, you need power, water, air, food, because you really can't provide enough coming from the Earth. You've got to find some way to grow it there. And it has a whole bunch of problems. I'd like to touch on just a couple of these. One is designing Mars habitats. Habitats actually have to do a lot of things, but the main job is to keep warm air in and deadly radiation out. The thing that most people think about doing is actually building habitats underground for protection against the radiation at Mars. That is going to require a lot of construction if you want to actually do that. In fact, you're probably going to have to get Elon Musk's Sporing Company to come in and dig the hole, okay? Another possibility is inflatable structures that you cover up with Mars soil. That's another way to protect it. I don't think we're ever going to see things like these cliffside condominiums, which some people have suggested, unless, of course, Elon Musk decides that's where he wants to live, okay? Anyhow, an interesting idea that came out of the Langley research area that would protect from radiation on the surface as opposed to under the surface is to actually inflate a shelter, fill the space between the two walls with water, let it freeze, basically make a giant igloo, because that's good protection against the radiation. So that's one possibility. But NASA's actually soliciting ideas from the community at large, and they have these challenges where people can propose different versions of habitats. These are some of the winners over the last couple of years. So this is an active area where people are very much involved in trying to figure out how to provide a habitat for Mars. Another option is actually to take advantage of something that probably exists on Mars, lava tubes. Lava tubes are caves that are formed by the flowing lava that when it cools leaves a tunnel behind. And there are these things on the Earth, some of the examples of which are shown right here. And they have a lot of advantages. They protect from radiation. They're at more or less constant temperature, so the big temperature swings we see on Mars aren't so much of a power problem. They protect against dust. They're scientifically interesting because they have a record of what processes were going on there, and they may be a place where life would exist on Mars if it exists there at all. And there is evidence that there may be lava tubes on Mars. These are thought to be skylights in a volcanic area of Mars, which may actually connect into something like this. So that's a possibility. Making rocket fuel and oxygen on Mars is important. We're going to have to be able to do that. Fortunately, that seems to be something we can do because Mars' carbon dioxide atmosphere and the water that we see there actually can be recombined to form methane, which is a fuel, and oxygen, which could be used to breathe. We can also break CO2 down this way to produce oxygen. There's an experiment on the Mars 2020 rover called MOXIE, which is actually going to test out this process. Can you extract oxygen from the Martian atmosphere? It's about the size of a car battery. If you're going to scale this up for human use, it would probably have to be about 100 times larger. There's another experiment on here, which I thought you might be interested in, and another second technology experiment. They're going to fly the first helicopter on Mars as part of the Mars 2020 mission. Oops, that happened again. There we go. The rotors on this thing have to rotate at 3,000 RPM in order to lift the body, which is about the size of a softball, okay, in the very thin Martian atmosphere. But we're going to test this out on the Mars 2020 thing. This will be incredibly valuable for helping to map out where we explore when we finally actually go there. There's a lot of work being done on simulated living under Martian conditions as best we can do it. 6 people recently spent a whole year in a 1,200 square foot geodesic dome in Hawaii, trying to pretend they were on Mars. They actually delayed communications with the outside by 20 minutes, as it would be in the case of Mars. They only went outside in spacesuits and performed experiments and things like that, like would actually do on Mars. There are a number of these things happening in various parts of the world. In Israel, for example, Utah, sponsored by the Mars Society, the high Canadian Arctic, and the Chinese have a base in the Gobi Desert. These things are important because they teach you whether or not you can actually survive living in a small group in very confined spaces. When this experiment was over, the reporter asked one of the women who was in this what she thought about her experience. She said, well, there were 6 of them in this. She said, well, there are 2 of them that I'll keep in touch with for the next few years. The problem with these experiments, as important as they are, is that the people know they can go home when it's over. Are we ever going to be in a situation where on Mars we can actually live out in the open atmosphere? This is the so-called terraforming situation. And the terraforming idea is we're going to turn Mars into something like the Earth. And the basic idea is very simple. Take all the carbon dioxide that there is on Mars, pump it back into get it back into the atmosphere, increase the greenhouse effect, warm up the planet slowly so that the ice becomes liquid, start planting green things, which will then, through photosynthesis, turn the CO2 atmosphere into an oxygen atmosphere, and thereby produce ozone. And so eventually we give up the shirt sleeve environment and swim in the new oceans of Mars. Can we really do this? The answer is no. We cannot do this, okay? And the reason is, there are actually 3 very important reasons. It's very, very expensive and takes a very, very long time. Optimistic estimates are $2 to $4 trillion in 500 years. Planetary Society thinks it'll take 10,000 years just to get to trees, and being able to go outside with an oxygen mask and a breathable atmosphere may take 100,000 years. Okay, required technologies don't exist and probably won't for centuries, but the real kicker is there's not enough CO2 on Mars. A recent study, okay, has shown that if you add up all the sources of CO2 on Mars, the stuff that's locked up in rocks, the stuff that's buried below the ground, the stuff that's in the polar caps and everything else, you add that all up, you get 7% of the amount that would be needed to warm Mars up to the point where the temperatures would be right. So Mars, in my view, is never going to look like this again, if it ever did, okay? We're always going to need complete protection from that environment. Living on Mars, we can probably do this. Not right now, but soon. Within the next few decades, we'll probably be able to send people there for a short time and bring them back. And maybe a few decades after that, we'll likely have the capability for a permanent human presence on Mars. But should we? What about the impact on Mars? As the dominant species, and especially as a technical civilization, I would argue we have not been very good stewards of our own planet's environment, its life, and its future. Whoops. Sorry about that. Putting humans on Mars, especially for the long term, will cause irreversible changes to the Martian environment and also to any life that might exist there. On Earth, we've created some real environmental ecological disasters. We fouled the air, ruined the land, poisoned the water. We've turned things that look like this into things that look like that, and things that look like this into things that look like that. Do we believe that just because we go to another place, we won't ever turn something that looks like this into something that looks like that? In addition to being messy, we're also full of germs. which we all too soon indiscriminately share. These are 13 different kinds of bacteria that live in the human body, which don't exist on Mars today, which will when we actually go there. And the problem is that enclosed environments are a great place for germs to actually survive. They've done experiments on ISS. Here's a report from earlier this year of the different kinds of microbes that exist on ISS, even though they try to keep it very, very clean. When you send robotic spacecraft to Mars, we can sterilize them, but we can't do that with humans. The trillion live bacteria on each human being that goes to Mars will be there with them. Do we risk contaminating the planet with Earth life that might compete with anything that actually exists on Mars? But Mars has no life, right? So it doesn't matter. The red planet is a dead planet, so we can't really kill it off. Wait a minute. Early Mars, when it first formed, was much more like early Earth when it first formed. On early Earth, the conditions were such that we had prebiotic chemistry that led to the origin of life. And if the conditions were the same, I would argue that could have happened on Mars. If life ever did exist on Mars before the catastrophic climate change, could it still exist today? We don't have any definite evidence of life on Mars yet, but absence of evidence is not evidence of absence. So is Mars sterile? I would argue we don't know. Here are 5 scenarios for possible life on Mars. Very pessimistic, life never arose, so we don't have to worry about it. Very optimistic that life found a way to survive, diversified, and still exists there today, okay? I think this is the right one, okay? I'm optimistic that primitive life arose on Mars, found a way to survive the catastrophic climate change when the magnetic field away in some protected environments, okay? And it continues to exist in those protected environments today, okay? The reason I think this is because of some research that has developed over the last 30 or so years about the Earth's deep biosphere. Okay, the Earth has what some people call deep and dark biosphere, where basically all aspects of Earth life, archaea, bacteria, and eukarya, all exist there, okay? Blind and adapted forms have learned to survive in the dark, finding non-photosynthetic ways to extract energy. Some of these things are thought to live for millions of years. Some of the examples are shown here, things from well below the surface, below the seafloor, down deep in mines and the like. The Earth has a deep biosphere. So here's what I would argue is a more plausible, more than just a plausible scenario. Earth and Mars, when they first form, have very similar conditions in the atmosphere and at the surface. So maybe life, prebiotic evolution, prebiotic chemistry happens on both worlds. Life arises in the form of very simple life, and then it occupies the available environments, including the deep biosphere. Then the magnetic field goes away, okay? So the atmosphere is now exposed to solar wind erosion, but it's lost slowly over time, billions of years. Mars slowly turns from being warm and wet to cold and dry. The deep biosphere won't be much affected by this surface change. The changes occur at the surface. The deep part below the surface could be very well insulated from that. So there might be some life that still survives down there. If Mars ever had a deep biosphere like the Earth has today, that life might still be there. Okay, so is or was there life on Mars? We can probably exclude some ideas. For example, no ancient civilizations, no canal builders, no fossilized trees, and that's not the source of the methane on Mars. Others, I think we have to be a little more careful about. The possibility that simple life could exist in a deep biosphere on Mars, I think, is something that we really have to take into consideration. And because we're not yet sure, we should be cautious. So I will leave you with some bad poetry. This is, remember, coming from the guy who wanted to be the first man to walk on Mars. To walk on Mars was once my dream, though lucky now that doesn't seem. For if the truth be really told, the years have passed and I've grown old. The trip out there, no easy thing. The cosmic rays can really sting. The zero-G is not much fun when 6-month journey is nearly done. I know that someday we will go, but now I think we should be slow to put our boots in rust-red dirt if something living we might hurt. It's true that Mars is cold and dry. That doesn't mean we should not try before the human horde arrives to know if something there survives. Living on Mars, or even just going there, is going to be very difficult, very, very expensive, and very, very risky. It's going to, I'm sure, cost human life and maybe Martian life. And my view now is that until we know for sure whether there's any indigenous life on Mars, okay, we should use the decades it's going to take to be able to actually go there to answer the question about whether or not there's anything there that's still alive, and make that part of our decision about whether we actually should. Thanks very much. I'll be happy to answer any questions that you may have. And as I said, I'm going to make a PDF of this available, so the details that we didn't actually cover, you'll be able to see if you want. Okay?
Thank you. Nice presentation, a lot of thought. Why should we go? What is the best story that would motivate investment of the resources needed to put humans on the planet?
This is a very, very important and serious question. Why should we go? I personally believe that actually the desire to explore is in our DNA. It's something that we do. Okay, it's part of our nature. Okay, is that a good enough reason to go? Maybe, maybe not. Okay, I don't buy into these arguments so much that we should go in case we make the Earth so uninhabitable that nothing can survive here and we have another place to be. I could easily argue that the trillions of dollars it would take to try to terraform Mars should be spent here to make the Earth more Earth-like. Okay, so it's a fair question. It's a very fair question. Go ahead.
What does Elon Musk have in his pitch?
Oh, because he's going to be charging people for the round trip to Mars. He's money. Yeah.
I have a question. I was wondering, I was disappointed about the terraforming. I was really hoping
Sorry,
that
it's not going to happen.
But you didn't mention the fact that if there's no magnetic field, wouldn't we be wasting our time? I mean, how would you even after 100 years with no magnetic field, wouldn't it just be
if you could pump the
obliterated?
atmosphere back up to levels it had, 4 billion years ago, okay, it would still take billions of years for it to erode back down to where it is now. It's a slow process. It's a slow process.
All right.
But it's an irreversible process. As you lose atmosphere, you lose the ability to keep the place warm.
So we'd have to get the magnetic field up and running again, right?
And there are wild ideas out there about how to restart the magnetic field. But the problem is that Mars is so cold in interior that it doesn't have the convective engine to do that. Yeah.
The National Geographic series entitled Mars that has been on, what's your perception of that, and does it make any sense what they've done?
Well, I think I've watched most of those episodes, okay? The one thing they couldn't do, of course, is to simulate the lower Mars gravity and have the people bounding across the surface. So they were walking around normally like we do here. A lot of what they actually presented there, I think, is very, very, very sound. I mentioned lava tubes, for example, looking for an existing subsurface place where one could actually establish a base, be protected from the surface environment, where there might be water still located. Things of that nature, I think were actually very, very well done. The whole question of whether life as it was being described in that series, you'd have to talk to somebody who's more of a biologist than I am to answer that question. I found it very entertaining, and I found much of the technical aspects of it very, very good. As I did for The Martian, for example. The Martian, the engineering details in there are really, for most of it, are really, really quite excellent. We know an awful lot, and so we can make these kinds of movies and things like that. I've gotten more interested in some of the things that we don't really understand, like, how will people really react when they know they're stuck there for 2 or 3 years, okay, and things of that nature. And this big issue of whether or not we're sure Mars is not going to be severely impacted by us actually occupying it. Every place on the Earth has been, okay? And so that's something that's come to worry me in my later life. Yeah. But it was a good series. Yeah, I enjoyed it.
Could I do it? Okay. Hey, my question is, you talked about, you showed some pictures of NASA, and their efforts. They're considering to go to Mars, but also like the Chinese and the Russians. And I was wondering your thoughts. Do you think getting a mission there, like a manned mission or whatever, do you think that would eventually be achieved as like something that a single country would do, or will we have to do that as a collaborative?
Okay, and this is where, as I said, my views may not coincide with that of the agency, okay? My view on this is very simple, okay? If we're going to go to Mars, we should do it as a civilization and not as just a single country. It should be something the world does, okay? Okay, and it should be a cooperative effort from everybody. That's my view. But that's just my view, okay? There are other people that think the only way we'll get there is if we actually have another space race. Who's going to be the first one to put the footprints on Mars?
Right. I guess, so my question is your feeling that the current situation does it look like they're collaborating or no? Yeah.
Okay.
Obviously,
I will tell you what I think. I think the current situation argues that we're not cooperating with anybody about anything, okay? And if that continues, no, okay? I am very hopeful that we will turn that around and go back to a situation which was, for example, in the previous administration, when we first started talking about building the gateway at the moon, okay, which is a totally international effort except for China, okay, which was forged because we wanted to do it in a cooperative way. That's where we should be. We're not there today, in my view.
Yeah, I just wanted to say I would be in favor of doing it just for no other reason than the unpredictable amount of technological beneficial spin-offs that come out of a program like that, if you look at the past space program and what it did for the electronic industry and computers and Tang. Don't forget Tang.
Don't forget Tang, yeah. No, I mean, being able to do that, for example, if you're going to be able to design a habitat that could exist under Martian conditions, you could live anywhere on the Earth. Anywhere, okay? So there is an awful lot of technological spin-off that could be realized from making this effort. I agree with you entirely.
Hi, great, very interesting.
My question is it's gone. Did the button get pushed? The battery's dead. I'll repeat your question. Go ahead.
So years ago, my question has to do with the people side on the colonization aspect. I know I had a taste of it years ago when I sailed a sailboat to Bermuda. We were 7 days in a small, boat, or a 36-foot sailboat, 6-7 people, through storms and all this adventure stuff. It was beyond anything I could ever really envision until I actually went on that experience, right? So it was a lot of stress, a lot of different things you're facing. Sure. I'm wondering if we even know that there's enough people even want to go colonize at Mars, for example. Go visiting and doing astronaut stuff, I can see that's kind of fun, that's exciting. We go, we come back. But, I mean, even if you look, I don't see a lot of people lining up to go to Antarctica, for example, to go doing that thing, and it's been there for 60-some years. So I wonder, is it even really humanly feasible that people want to do that kind of stuff? Because,
yes.
Because I had a taste just being in a sailboat, and I'll tell you, it's extremely different than what you think it's going to be.
Yeah.
I can understand people say, oh, I'd love to go, but when you actually go do that kind of stuff, it's dramatically different than what you're imagining, especially harsh environment that's orders of magnitude more harsh in Antarctica, isolation, all that stuff is, I don't know, have we actually done realistic, things to say there's enough people even, it's even worth even trying to colonize?
As an example, that demonstrates that there are people who will do anything, okay? There was a program called Mars One, okay, that is now defunct, where this venture capitals group, I think from Denmark originally, proposed sending people to Mars on a one-way trip. You would never come home, okay? They got hundreds of people to sign up for it. Hundreds of people to sign up for it, knowing they would never come home. Now, part of that could be argued they didn't really know what they were getting into, as you say. Right. And I think that's exactly true. None of us know what we're getting into, okay? This is bigger than anything anybody has ever attempted, okay? And as I said before, the simulations are done where they put people for a year in a geodesic dome, okay? They know they're coming out, okay? You're right. People don't really know what they're getting into, okay?
Right. Well, my case is, for example, Antarctica is probably your closest example.
Right.
I don't see 100,000 people living there in Antarctica today. So that would tell me that, I think that's a huge challenge of, is it worth even going for, say, you find 6 people who want to go live there. Is it worth trillions and trillions of dollars to do that?
So at McMurdo,
question.
you have 250 people that winter over. They're basically there year round. And you have another 1,000 people that come at the summertime to do science in the summer season, okay? Maybe that's the better analog. We go there, we do something, and we come back. We don't try to stay there. That might be the better way to do it.
Yeah. So, now the big hand for Dr. Frey.